Hey everyone, today we're moving on to Chapter 1, Lesson 3, Day 1, Multiply and Divide Monomials. Our objective is to simplify real number expressions by multiplying and dividing monomials. Again, don't forget to gather the materials you'll need and watch for these keywords in the videos. We're starting out with product of powers, and what product of powers means is to multiply powers with the same base, you have to add their exponents. So this is just kind of operation we use when we've got exponents with our bases. In this case, we've got 2 to the 4th times 2 to the 3rd. The way we evaluate these types of problems is we take our exponents, and in this case, since we're multiplying, we take our exponents and we add them up. So we've got the same base, 2 to the 4th and 2 to the 3rd. That means we can take our exponents and add them. So that would become 2 to the 4 plus 3, or 2 to the 7th. And algebraically, using variables, we could have a to the m times a to the n, which would simply mean a to the m plus n. So the key thing is here, we have to have the same base. In this case, we have the same base of 2. In this case, we have the same base of a. A monomial is a number, a variable, or a product of a number and one or more variables. You can use the laws of exponents to simplify monomials. So, for example, here we've got 3 to the 2nd times 3 to the 4th. 3 to the 2nd, we have 2 factors. 3 to the 4th, we have 4 factors. That would give us a grand total of 6 factors, or 3 to the 6th. So again, we've got the same base. We're just adding the exponents because we are multiplying. So notice that the sum of the original exponents is the exponent in the final product. So let's look at a couple examples. Number 1 asks us to simplify using the laws of exponents. So we've got the same base, 5 to the 2nd times 5, which is 5 to the 2nd times 5 to the 1, or 5 to the 1st. We have the same base, which is 5, so we can add our exponents, so that would become 5 to the 2nd plus 1, or 5 to the 3rd. And when we multiply that out and simplify or evaluate, we get 5 times 5 is 25, and 25 times 5 is 125. Here we've got an example with variables. We've got the same base, c. So c to the 3rd times c to the 5th becomes c to the 3 plus 5, which is simply c to the 8th when we add the exponents. Now we've got a little more complex problem. We've got negative 3x squared times 4x to the 5th. So what we have to do is we have to use the commutative and associative properties to separate out our values. So we're going to take our whole numbers. Here we've got negative 3 and positive 4. We're going to group them in parentheses, negative 3 times 4. And then we're going to take our exponents, x squared and x to the 5th. Our like base is x, so we can multiply x squared times x to the 5th. When we work through our problem, we get negative 3 times 4 is negative 12. X squared times x to the 5th becomes x to the 2 plus 5. And our final answer is negative 12x to the 7th. So let's try an example. For a, we've got 9 to the 3rd times 9 squared. We've got like bases with the 9, so we can write that as 9 to the 3 plus 2, which we equal 9 to the 5th. And then we evaluate 9 to the 5th, which is 9 times 9, 5 times. We get 59,049 for our final answer. So now I'd like you to try these. B and C. Please pause the video, work through B and C, then come back and see how you did. For B, we've got a to the 3rd times a squared. Our like base is a, so we could rewrite that as a to the 3 plus 2, which would just simply be a to the 5th. For C, we've got negative 2m times negative 8m to the 5th We group our like terms. So that would give us negative 2 times negative 8. And then m times m to the 5th. Negative 2 times negative 8 is positive 16. And m times m to the 5th would be the same as saying m to the 1 plus 5, which would equal m to the 6th. So our final answer would be 16m to the 6th. Now, in contrast to what we were just talking about, the quotient of powers means to divide powers with the same base, we'll need to subtract their exponents. So say, for example, right here we've got 3 to the 7th over 3 to the 3rd. So when we're dividing with exponents, we actually subtract the exponents. Again, we have to have the like base, so we have to have a base. In this case, our like base is 3. So 3 to the 7 over 3 to the 3rd becomes 3 to the 7 minus 3, or 3 to the 4th. Now, in algebraic terms, we could look at it like this. A to the m over a to the n would equal a to the m minus n, where a does not equal 0. There's also a law of exponents for dividing powers with the same base. In this case, we've got 5 to the 7 over 5 to the 4th. So for 5 to the 7th, we've got 7 factors. For 5 to the 4th, we've got 4 factors. When we subtract our 7 factors and our 4 factors, we end up with 5 to the 3rd, or 3 factors of 5. So notice that the difference of the original exponents is the exponent in the final quotient. So again, 5 to the 7 over 5 to the 4 would be the same as subtracting 5 to the 7 minus 4, which would equal 5 to the 3rd. So for example 4, we are going to simplify using the laws of exponents. Again, we have to have a like base, so we've got 4 to the 8th over 4 squared. Our like base is 4. 4 to the 8th over 4 squared becomes 4 to the 8 minus 2, or 4 to the 6th. Then when we multiply out 4 6 times, we would end up with a final value of 4,096. For 5, we've got n to the 9th over n to the 4th, which would be n to the 9 minus 4, or finally n to the 5th. Problem 6 is a bit more complex. We've got 2 to the 5th times 3 to the 5th times 5 squared over 2 squared times 3 to the 4th times 5. So again, we're looking at taking our like bases and subtracting their exponents. So we've got 2 to the 5th over 2 squared, 3 to the 5th over 3 to the 4th, and 5 squared over 5. So 2 to the 5th over 2 squared becomes 2 to the 3rd. Just subtract 5 and 2. 3 to the 5th over 3 to the 4th becomes 3 to the 1st. Just subtract 5 from 4 to get 1. And 5 squared over 5, or 5 to the 1st, there's an understood 1 there. So 2 minus 1 would be 1. So now we can evaluate. 2 to the 3rd becomes 8. 2 times 2 times 2. 3 to the 1st becomes 3. 5 to the 1st is 5. Multiply 8 times 3 to get 24. 24 times 5 to get 120. So again, let's try a few examples. Let's start with D. D is 5 to the 7th, or 5 to the 4th, which would equal 5 to the 7th minus 4, or 5 to the 3rd. And when we simplify 5 to the 3rd, we get 125, or 5 times 5 times 5. Next, E. We've got x to the 10th over x to the 3rd, which would equal x to the 10 minus 3, or just x to the 7th. Moving on to F. We've got 12w to the 5th over 2w. So now again, we have to look at like terms, so we have to take our whole numbers, which would be 12 over 2, and then our variables, which would be w to the 5th over w. 12 divided by 2 would be 6. W to the 5th minus 1 would simply equal w to the 4th. So our final answer would be 6w to the 4th. Now let's look at a couple more complex examples. So let's start out with g. So for g here, we've got 3 to the 4th times 5 squared times 7 to the 5th over 3 squared times 5 times 7 to the 3rd. Now I need to group my exponents by like bases. As you can see here, I've got my 3 as a like base, my 5s, and my 7. So I can just rewrite these as separate fractions. So I'm going to get 3 to the 4th over 3 squared times 5 squared over 5 times 7 to the 5th over 7 to the 3rd. And now I just subtract. So 3 to the 4th over 3 squared becomes 3 squared. So 4 minus 2 became 2. 5 squared over 5, or 5 to the 1, would become 5. And then 7 to the 5th over 7 to the 3rd, 5 minus 3, would become 7 squared. I'm multiplying all these, so I need to put my multiplication dot between each. And now I continue to simplify. 3 squared equals 9 times 5 times 7 squared is 49. And now I just multiply straight across. 9 times 5 is 45. And 45 times 49 equals 2,205. So now I'd like you to try these last two on your own. Pause the video, work them through, then come back and check your answers. So for h, I've got 5 to the 6th times 7 to the 4th times 8 to the 3rd over 5 to the 4th times 7 squared times 8 squared. Again, group these like bases. I'm just putting in parentheses so you know where I'm going. So that becomes 5 to the 6th over 5 to the 4th. 7 to the 4th over 7 squared. And 8 to the 3rd over 8 squared. And to work these through, 5 to the 6th minus 4 is 5 squared. 7 to the 4th over 7 squared becomes 7 to the 4 minus 2, which is 7 squared. And then 8 to the 3rd over 8 squared is 8 to the 3 minus 2, or 8 to the 1st. Now I evaluate. 5 times 5 is 25, or 5 squared is 25. 7 squared is 49. 8 to the 1st is just 8. And multiply straight across. 25 times 49 is 1225 times 8, which is 9,800. And for our last example here, problem I, we've got negative 2 to the 5th times 3 to the 4th times 5 to the 7th over negative 2 squared times 3 times 5 to the 4th. Again, I group by like bases, and that gives me negative 2 to the 5th over negative 2 squared times 3 to the 4th over 3 times 5 to the 7 over 5 to the 4th. And now I've got negative 2 to the 5th minus negative 2 squared, so negative 2 to the 5 minus 2 becomes negative 2 to the 3rd. 3 to the 4th over 3 becomes 3 to the 4 minus 1, or 3 to the 3rd. And then 5 to the 7th over 5 to the 4th becomes 5 to the 7 minus 4, or 5 to the 3rd. Negative 2 to the 3rd becomes negative 8, which is negative 2 times negative 2 times negative 2. 3 to the 3rd becomes 27. 5 to the 3rd becomes 125. Then when I multiply, negative 8 times 27 becomes negative 216 times 125 equals negative 27,000 for my final answer. So your assignment for tomorrow is page 27, just the odds, number 1, 3, 5, 7, and 9. Please make sure to follow the assignment checklist, show all your work, and turn your final copy into Canvas when you're finished.